Hi, we're going to analyze this problem regarding graph theory. We're going to analyze a tree that, a data structure initially was a tree, but there was turned into graph with a redundant connection, creating a cycle, meaning that initially this graph was acyclic and then became cyclic. So we have a tree that is undirected, an undirected graph that is connected and has no cycles first. This is the problem. Having n nodes labeled from 1 to n um, with an additional edge added, and then creating this redundant connection that we can see here. And we have to return, for example, in this case, what is the redundant connection? Like this case, and in this case, it will be this um, edge. As we can see, we will just go from 4, 3, 2, 1, and 5 without having this cycle. And in case there are multiple answers, to return the answer that occurs last in the input. In this problem, we could do breadth first search or depth first search for cycle detection. The problem is that the complexity of that will be O(n) to the power of 2, and it will be unacceptable for a competitive solution. So the solution and the approach that will be followed is the union find, basically this joint set union DSU that has two main components. Find that is going to determine um, the subset element of X that is in it. For example, in this case, in the edge, is going to determine what is the parent of the subset. Meaning, if I want to go from say 3, what will be the parent of this, and say with 2, and then the union by rank, the union will like just join two subsets containing X and Y. We're gonna do path compression in the fine operations, making one node point directly to the root to plan the data structure, and union by rank. So we are gonna do this. Uh, so we prevent the tree just becoming a linked list in this Q case, and just adding the shortened tree to the taller tree. To start this, first we're gonna create the internal structure of DSU for encapsulation. So we're gonna create this struct DSU, and in DSU we're gonna have the vector of integers that are gonna represent the nodes of the graph. We're gonna have the parent that is gonna represent the hierarchical structure of the graph. We're going to have the rank that is going to help us to um, add the subsets in the tree. We're going to have the constructor of the DSU that is going to have this argument, input argument, the constructor, the number of graphs. Then we're going to have parent, and we're going to have rank. For parent, the dimensions, as we can see, as nodes are labeled from 1 to n. For convenience, we're gonna label the parent from 1 to n. And this we're gonna do it with the resize method from the vector. And from the rank, we're gonna do similarly, naming them from 1 to n and filling first all values with 0. And to store the parent, the values, we're going to use IRA, that is going to be more efficient than just doing a loop. This is a efficiency technique to have like um, to use these loops in the solution is going to be more optimal. So we're going to use for parent, we're going to go from the pointer to the first position in the begin, and then parent, we're going to go all the way to end, and we're going to fill with zeros. So what we're doing in this case is just filling with parent. In the ith position, we're just filling with the value of I, meaning like in the beginning, every node basically is its parent. Like in the beginning, one is has a parent one, two has a parent one, and three has a parent one. This is like the first initial assumption in the algorithm. Then we're gonna go to the find method. Then we're gonna having the structure for again for encapsulation. In the find method, we're gonna use path compression, and in find, we're gonna do it for the node x. So in this case, for the logic of find, we're gonna do that if the parent of the node x it's not equal to x, so we're gonna do that the parent node is gonna be equal to find the parent index position, and we're gonna return parent of x. And then we're gonna use the union by rank that is gonna return false if there's a cycle and true if the merge was successful. So where the return type is gonna be a bool variable, and we're gonna have unite with the two elements of the subset that is gonna be the edge, meaning that if, for example, we have 1, 2, we have 1, 3, we have 2, 3, we are gonna see that we are going to merge um, this into this edge, where we can see that the parent of 3 is 1, and the parent of 2 in this case is also 1. So as they're going to share their parent, that means that there's a cycle. And that's the logic that we're going to follow. So we're going to do for the root of the x node is going to be find the parent of x. And also the parent of the another node in the link. And we're going to find the parent of y. If the root of x is equal to the root of y, then we're going to return false as there's a cycle detected. And then to merge the trees, we're going to use the rank in order to merge the smaller trees into the higher trees. So we're not going to have a skewed tree. And we're not going to have like an unmanageable, like tall linked list. So if the rank that initially is for both cases is 0, if the rank of x is less than the rank of root of y, what we are going to do is that the parent of root x is equal to root y, where basically we are merging one small list into a bigger list, like in this case. If we have the opposite case, the case that this is the opposite, then we're gonna invert this. Then in the default case, we're gonna have that the parent of the root y is equal to root x. And we're gonna add to the rank of x. And we're gonna return true in case we could merge the nodes. Here I have a typo. Finally, in the solution, I will have the variable n that is number of edges. So here I will have the variable n. I will call the constructor of TSU and will pass this variable instantiating the variable, and I'm gonna iterate through all the edges. This will be the first node of the edge, and here I will have the second one. Here I'm gonna call the algorithm, the instance calling the unite method with both nodes, and we're gonna return the edge. So in case this fail, what I'm gonna do is that I'm gonna return the list where I couldn't merge the both of the list because they share the parent. For example, in this case, we could merge these two lists, but we couldn't do this because the parent will be the same for these two cases, in which case this will yield a false, and I will just return the edge in this case. In accounting, like something goes wrong, I will by default return an empty list. Here I have an error. It would be resize. Okay, and here I'm missing a semicolon. Here it will be the variable n as is the number of edges. And here will be the final solution for this problem.